All right, so next, division. There's a couple ways to think about division that we looked at last week. And for the using the toys like the pattern blocks, the easiest thing to do is the idea of groups in. So division of fractions. Division means groups in. And so let's take, for example, how about 3/4 divided by 1/3. And so what does that mean? That would mean how many groups of 1/3 are in 3/4, right? Because the 1/3 is going into 3/4. So I'm going to do this a couple of different ways. I'm going to do it first by drawing some rectangles for fractions, and I'll do it with the pattern blocks that we played with. So how many groups of 1/3 are in 3/4? The way to think about that is kind of like long division. 1/3 goes into 3/4 how many times? So what we're going to do is we're going to show what a third looks like and show what 3/4 looks like to figure that out. So I'm going to draw 1/3 as a square cake and split that into thirds. There's my best thirds. Oh my gosh, the sun's out here. And then we're going to take that into 3/4. So I tried to draw the same size hole. I'm a little messy today. And like I did with addition and subtraction, I'm going to draw them in opposite directions. And so let's shade. So let's say this is the third. We're going to try and piece into 3 of these fourths. All right, so a third is smaller, so I can kind of guess at this and say, well, the answer is going to be more than 1, because for sure this is smaller than that. But the problem is these cuts are different. So then we'll take the approach we did with addition and subtraction, where we'll cut each like the other. So I'm going to cut the fourths into thirds, and the thirds into fourths. So now another way to think about this is I have 1, 2, 3, 4 pieces there, and I'm looking for those pieces in this region, which has 3, 6, 9. So how many times do these 4 pieces go into these 9 pieces over there? Well, 4 goes into 9, like we can look at that and see it. To screen maybe. There's one group of 4 right there. There's another group of 4 right there, and there's 1 left over. So it looks like we're going in there 2 whole times. But what do I do with this leftover piece? What is that? 2, and Montse says a 4th. And yeah, that's because we're looking for 4 pieces there. So there's 1 out of the 4 pieces that we need in there, which is kind of cool. So not too bad, I don't think. So 1/3 goes into 3/4, 2 and 1/4 times. For those of you who prefer improper fractions, 4 times 2 is 8 plus 1 is 9. That would give me an answer of 9/4 would be the other way to think about it. And notice there are 9 pieces here, and I was looking for 4 at a time. So that's another way to justify that 9/4 there. So a couple different answers there to justify this. Why do I get 9/4 or 2 1/4? Because 2 reasons. 1, division means groups in. How many groups of 1/3 are in 3/4? And the other is a fraction is an equal part of a whole. I had to use that to draw this picture. Okay, so these two facts here allowed me to figure out what the answer is. And an algorithm is another thing we'll talk about in a minute. So next I want to try this using those other toys, the pattern blocks. And for that, I think I'll use the pattern block app here. In order to create 3/4 with these, then a whole has to be 2 of these. So these 2 pieces is going to be a whole. So I'm just going to throw some text on there that says that. 2 hexagons. Stick that on top here. So that's kind of my key to work with. Otherwise, I'm trying to take 1/3 into, so just write down the question again. How many groups of 1/3 are in 3/4? Is the question again. We're going to try and answer these toys. And so I'm going to set up the long division style to do that. So I have to show what 1/3 looks like inside of a whole. And I have to show what 3/4 looks like inside of a whole. So let's draw a little division box and then make 1/3. So let's see. Since one of these is 1/3 of 1, then 2 of those is 1/3 of 2. So this right here is my 1/3. And then I have 1, 2, 3/4. So I got to figure out how many of these go there. And at the moment, right, they're different sizes. They don't line up. So I can try to place these on top. There's certainly one approach we could take. So there's one of them. And then over here and here is another, right? So there's one chevron, there's another chevron, then I get that extra piece right there. And that gets a little hard to figure out. So usually what we do instead is we would just say, okay, we need a common denominator piece. And so that's going to be some triangles. So this is kind of like what I did with the other picture. I had to kind of find a way to draw each like the other. Oops, I messed that up. Careful, if you click in the wrong spot, you get to switch who's on top. My mouse is making that funny noise. There. So having the physical things in front of us is much easier than this app. All right, so refiguring out my answer, I should make a note. Or triangles. To make 1/3. See. Then I'll just start finding them. So let's see. So I'm looking for a group of 4 triangles. So 1, 2, 3, 4. There's 1. 1, 2, 3, 4. There's 2. And then I have this, which is 1 out of the 4 I want. So I get 1, 2, and then that's 1/4. So restating that, there are 2 1/4 groups of 1/3 in 3/4 is the conclusion. All right, you guys ready to try one? So again, the goal here is not to first use an algorithm to come up with an answer and then try and use a toy or a drawing to justify it. It's the other way around. It's to say, this is what division means. This is what a fraction means. Based on what division means and what a fraction is, can we come up with an answer? And then we could justify it later. So just another note on that. Eventually, we've got a couple of algorithms, so I might as well go over those before I split you guys up again. Here's my drawing pad, there it is. So fraction algorithms, there's 2 of them basically. Fraction division algorithms, that is. So the one I mentioned the other day, based on the drawings that I was doing, was is the common denominator version, which is an unusual method, but it works. So there's a common denominator algorithm. And actually, I guess there's 3. There's an arrow algorithm. And then 3, there's the multiply by the reciprocal algorithm. So the common denominator algorithm for something like, let's see, what we have? 3/4 divided by 1/3 says, well, find a common denominator. Okay, so common denominator here would be 12ths. And so then I would get 3 times 3 over 4 times 3 divided by 1 times 4 over 3 times 4. So that's going to be 9/12 divided by 4/12. And then you just forget about the denominator. The answer is 9 divided by 4, which you could then state just as 9/4, or 4 goes into 9 twice with 1 left over, or 2 1/4. Okay, so you find a common denominator. And then you adjust the fractions. And then you throw away the common denominator. And there's the answer, 9/4. Arrow algorithm works kind of in reverse of some of the other ones. Starting with the second fraction, we draw arrows in opposite directions. So 3 times 3 is 9, 1 times 4 is 4, so the answer has got to be 9/4. So that's the arrow algorithm. And the multiply by the reciprocal algorithm is kind of the standard one. 3/4 divided by 1/3 is equal to 3/4 times the reciprocal, which is 3 over 1. And we all know how to multiply numerators, multiply denominators, and there's 9/4. That's supposed to be a 3 right there. That's a little better. So none of these algorithms explain why should the answer be 9/4. Why does this work? All they do is say, just do this and shut up and you get an answer. Okay, so ultimately, we need to know 2 things as teachers. We need to know how to get the job done for any numbers we're given. when I draw these pictures, I kind of have to pick the numbers carefully, otherwise the pictures are too unruly and difficult to deal with. So when demonstrating why, we got to be careful about the numbers we pick. For the algorithms, it doesn't matter what number you pick, so just follow those rules. Either draw the arrows in the right directions for your multiplication, multiply by the reciprocal, or find a common denominator and then chuck it out. These all work, they all give exactly the same answer, but none of them in any way says, why does this work? Why can you do that? How did you do that? I didn't, there's nothing to do with why, it's just do it. Do it because I said so. Which is the way a lot of us learn math. Somebody just said, hey, do this, you get the right answer. And we said, okay, and we practiced it till we memorized it. As a teacher, you need to be more than that. You need to know why should that be the answer in the first place. And to do that, we have to say, well, this is what division means. This is what a fraction is. So that's how we get the answers we have. And then algorithms are kind of built on these why, and they turn into a how. So I'm going to have you guys try to show one. And I think we're going to need, so the Jamboard I found very painful to draw with the mouse, and you can type text. I'm leaning toward using this instead of the Jamboard. Any thoughts from you all? Pattern Block app or the Jamboard to try and, for you guys to try and as a group agree?
I think Pattern Block. What do you think?
That's what I thought. Anyone else? Patterns, Avali says, yeah, I think this is a little easier to use than the Jamboard. Okay, so we're gonna do this. I'll just put the link to this. Now the link I'm gonna send is not the link to mine, it's a link to a blank one. So using this app here, if you wanna share with other people, if you go to the link at the top and you send somebody that, they'll just get a blank Jamboard. So I'm just gonna demo that. I'm gonna put that down there in the bottom. And if anyone goes to the chat and clicks that link, they're going to end up with a blank one of these, right? So if I copy this, put it in a new tab, paste, enter, it's a blank. I call it Jamboard. It's a blank pattern block board. If I want people to actually have this work right here, they have to go down to the share link at the bottom. So this is kind of similar to Google. If you give me the link at the top of a Google sheet, I can't use it. I need the share link. So this one right here is my version of it there, which I'll give you too if you guys want. So copy. So the one coming here is my justification of the 9/4 answer for these. So you should notice that that's a different website. All right, so let's see. What is going to be our problem? Let's get a new one. And how about 2/3 divided by 1/4 is what I want you to show with the pattern blocks. And I don't want you to use an algorithm, I just want you to use division means groups in. So in other words, for this, the question you're going to try and illustrate is how many groups of 1/4 are in 2/3. And so you'll have to draw that out with the pattern blocks, find a common denominator, and have a brief justification there. So I'm going to reset the groups here. Breakout rooms, how do I do that? Not there, not there.